Okay, so we are going to move into Tuesday 10.1, Fundamental Principle of Counting. Now, the fundamental principle of counting is something that connects with what we learned yesterday. Yesterday we learned all about trees, and if we want to look back at that, we can quickly. Remember, we talked about how we could use trees to map out these different possible scenarios. Now, in this situation, drawing the tree didn't take too long, but we could draw trees that are much bigger. Let's say we have 5 pairs of pants and 6 different t-shirts and 7 pairs of socks. Our trees would be huge. And we are going to learn a method today where we don't need to draw a tree. Now, we are actually going to use the same problem, but we're going to use the fundamental principle of counting. And the fundamental principle of counting says this. I'm going to read it, and it may sound a little confusing, but then we'll talk about it. If one step can be done in M ways and another step can be done in N ways, then the two-step process can be done in M times N ways. So again, we have the same problem. We want to know how many different possible arrangements of outfits he can make if he has 3 pairs of pants, 2 shirts, and 2 pairs of socks. Now, the fundamental principle of counting says it can be done in M ways and then N ways, and we multiply them. And another way to think about this is the number of options for each choice. That's another way to think about it, the number of options for each choice. So the first choice he has to make is is what pants to wear. And he has how many pairs of pants? 1, 2, 3 pairs of pants. He has 3 options. His next choice he needs to make is t-shirts, right? And we could label these. You don't need to. Pants is the 2, or is the 3. Then he has 2 t-shirts, so he has 2 choices, okay? And again, you don't need to label them. I'm just showing you what these mean. And it says that we are multiplying these. Now notice in this problem, it's not just 2 choices. There's a third choice, which is socks. And there's 2 different colors or 2 different pairs, so we are going to multiply by 2, and that's the socks. All we do now is multiply across. 3 times 2 is 6 times 2 is 12. Looking back at our tree yesterday, that is what we got out. We got out 12. So we can see that this fundamental principle of counting works. There are 12 different arrangements or combinations here. Now, one thing to notice with this is, do we know what those combinations are? No. The tree does a good job of showing all of them, but if you just want to know how many, this is a really slick way to do it quickly. All right, let's move to example 2. In example 2, it says, find the number of ways to elect a president. Sorry, it's not quite fitting. Find the number of ways to elect a president and senator if there are 5 people on the ballot for president and 3 running for senator. So here's what they're saying. If we have 5 people running for president, so let's say we have Tina, we have Chris, we have Mackenzie, we have Grace, and we have Elizabeth running for president, okay? And then we have Noah, and we have Luke, and we have Mason running for senator. How many different combinations could there be? So we would pick one president. So let's say we pick Chris for president, and let's say we pick Luke for senator. That would be one combination. Or it could be Luke and Noah, right? So there's all these different combinations, and we don't need to know names or anything like that. Remember, we just multiply the number of options. So, first of all, we have to think about the president. How many options are there for president on the ballot? Well, in this problem, there are 5 options for president. And how many options for senator? Well, there are 3. And what do we do with those 2 numbers? According to our instructions up above, we multiply. So there would be 15 possible arrangements of president and senator. All right. Let's move along. Oh no, my pages are out of order. All right, here we are. To example number 3. Example number 3 says find the number of 3-digit numbers using the digits 5, 6, and 7. Now, In this problem, we could write out the options. We could write 5, 6, 7, 6, 5, 7, but we can use the fundamental principle of counting. Now, it's going to look a little bit different. We are going to make a 3-digit number. Now, one thing that I find helps students understand this is to create these blanks, okay? We're going to make a 3-digit number, so we need 3 blanks. Now, you don't have to do it this way, but I find that a lot of students kind of click or connect with this way. So we're going to create a 3-digit number. Now, they want it only to be of the digits 5, 6, and 7. So, how many options are there for this first number? How many different things could you choose here? Well, you could put a 5 here, or you could put a 6 here, or you could put a 7 here. So there would be 3 options, right? Now, in the second spot, what are our options? Well, we could put a 5, we could put a 6, or we could put a 7. So there would be 3 options as well. Now, over here, for our third digit, what are our options? Same options, right? 5, 6, 7. So there's 3. And after we've laid them all out, all we simply do is multiply. 3 times 3 is 9 times 3 is 27. So that means there are 27 different arrangements. Now, if you wanted to double check this, or if you were on a test or you had a homework assignment and you weren't sure, could you write them all out? Yes, 5, 5, 5, 5, 5, 6, 5, 5, 7, and you should come up with a total of 27. Now, do you need to do this? No, that's the whole point of the fundamental principle of counting, but this might be a good way to check your work or to think through it. All right, let's move to our last example of the day. Now, the last example is very similar, so we'll show them both. It says, find the number of 3-digit numbers using the digits 5, 6, and 7. Now, here's the kicker, without repeating digits. Okay, so we're going to do the same thing. It's a 3-digit number, so we're going to make 3 blanks. Okay. Now, this one's a little bit tricky, so let's think about it together. How many options are there for the first digit? Well, we have 5, 6, or 7. So we'd say 3. Okay, so far it looks the same. Now, they say without repeating. So can you use all 3 of them again? No, we used one of them. So how many choices would be left after you use one? Well, 1 less than 3 is 2. All right, now we've used one of the numbers here, 5, 6, or 7 here. Then there's 2 left here. How many options do we have left for the third digit? It would only be 1, right? So, and let's quick talk about it before we multiply across. In this problem, when they say without repeating digits, we can't just say 3 times 3 times 3, because each time we use a digit, we cannot use it again. So here we had 3 digits, but now that we've used one of those, we only have 2 options left. And now that we've used those one of those 2 options, we only have 1 option left. Okay? Now we're ready to multiply 3 times 2 times 1. And 3 times 2 is 6 times 1 is 6. So there would be 6 possible arrangements. Now, again, especially with 6, it's a pretty small number. You could check to see if that's true. Would 5, 5, 5 be an option anymore? No, because it's without repeating. So we'd only be able to do numbers like this. 5, 6, 7, 5, 7, 6, 6, 5, 7, and so on. Okay, there will be 6 total of them. So if you wanted to do this, you could. But again, the whole point is to use the fundamental principle of counting. Moving to your homework, let's go over it again, or just like we did yesterday where we kind of talk through them and think about how we would set them up. So today you're using the fundamental principle of counting. If you're uncertain, you could use a tree, but I think most of you are going to find the fundamental principle of counting to be something that's really helpful and quicker. So first problem says, find the number of ways to choose a hat and coat. Okay, so you're choosing a hat and coat. The hats are gray, blue, red, and green. Okay, so these are your hat options. I'll circle those for you. And your coat options, you have a black and you have a gray coat. We want to know how many different ways could you choose a coat and a hat. So you could have a black coat with a blue hat, or you could have a gray coat with a green hat, okay? So there's all these combinations. Now we could think of them, but we could much more quickly use that fundamental principle of counting. And I think a lot of you can just look at that and do it mentally. All right, find the number of 4-digit numbers using the digits 4, 5, and 6 or 4, 5, 6, and 7, without repeating digits. This is very similar to example number 4, the one we just did up here, because it says also without repeating digits. The only difference is this one was 3-digit and this one is 4-digit. So pay attention. I'm going to mark the important things here. It's a 4-digit number and it says without repeating digits. Okay. All right, and homework problem number 3, find the number of ways to choose a friend and a game to play if the friends are Kristen, Luke, and Tucker, and the games are basketball, soccer, and tennis. So let's say, here's what they're asking. What are the combinations of friends and games? So you could play basketball with Kristen, or you could play soccer with Luke, or you could play soccer with Kristen. Okay, so there's all those combinations. Using the fundamental principle of counting, I want you to tell me how many different ways could you choose that. And again, I'll circle the important parts. The friend options are Kristen, Luke, and Tucker. Okay, and then the games are basketball, soccer, and tennis. So, without further ado, get started on these 3 homework problems. I'll see you guys tomorrow.